Hi everyone, today we're going to learn about the last section in this chapter, which is modeling with systems of equations. So we've been working a lot with solving systems of equations, and now we're going to use them to represent real-world problems. And that's what we mean when we say we're modeling. We're using these equations to represent real-world problems. So now we'll have some context behind these equations that we're working with. And in fact, we're going to have to create the equations that we're going to be solving. So when we're modeling a real-world situation, sometimes we need more than one equation to represent the problem. So in order to do this, there's a few steps we can follow to help us kind of streamline the process. So the first thing we're going to do is identify our variables. And what's really important here is that we need to have the same number of equations as variables. And we're going to get to that pretty soon in the first example. So then we're going to write the appropriate number of equations. Mostly for now, we will need 2. And then once we've set up that system with the 2 equations, we're going to solve it using either substitution or elimination. So the whole chapter has really been preparing you for step 3. It's just going to be step 1 and 2 and actually writing those equations that's new. So let's jump into a problem and see what this is going to look like. Now, an important thing here is when we're identifying the variables, really what we're doing here is we're looking for the unknowns in our problem. So the unknowns or the missing information. And that's how we're going to determine what our variables should be. So when you're reading a problem, I want you thinking about what is missing, what am I being asked to solve, and that's going to help you find your variables. So in number 1, it says the school that Jacob goes to is selling tickets to a fall musical. On the first day of ticket sales, the school sold 4 senior citizen tickets and 12 child tickets for a total of $140. The school took in $100 on the second day by selling 8 senior citizen tickets and 6 child tickets. So it says to find the price of a senior citizen ticket and the price of a child ticket. So that's the information we don't have. We know how many were sold, but we don't know the price of a senior citizen ticket and we don't know the price of a child ticket. So for step 1, that's my unknown or my missing information. So I'm going to set up a variable for each. So since this is a senior citizen ticket, I'm going to call that S. And I'm going to say S equals the price of a senior ticket. And for this, it's a child ticket, so I'm going to let that be C equals the price of a child ticket. Now make sure you do not skip this step. You have to define very clearly what your variables are before you write your equations. So now, thinking back to point 1, it says you will have to have the same number of equations as variables. So since we have 2 variables, we're going to need to write 2 equations. So we're going to make sure before we leave step 2 that we have 2 equations. So let's see what information we have that is going to help us do this. So it tells us in the problem, on the first day of ticket sales, the school sold 4 senior citizen tickets and 12 child tickets for a total of $140. So I'm going to say 4 senior citizen tickets plus 12 child tickets I know earned us $140. So that's going to be my first equation. I'm going to say 4S plus, we had 12 child, so 12C, and that gave us a total of $140. And actually in your equation you don't need the dollar sign. Then we have a second bit of information. It says they earned 100 on the second day by selling 8 senior citizen tickets and 6 child tickets. So now I know I have 8S plus, let's see, what was it? 8 senior citizen and 6 child. And that took in $100. So that's step 2. We've got our 2 equations that we said we needed, and now we're just going to solve them. Now, one thing I noticed because of the way I set this up, S's are over S's, C's are over C's, so I'm kind of set up for elimination. Now I just need to make it so that one of my variables drops out. So I notice I have a 4S and an 8S. So if I multiply this by -2, I can make those S's cancel out. So I'm going to move this over here for step 3. Now I have -8S plus 12C is equal to, this would be -280. Then I have 8S plus 6C equals 100. And so I notice here my S's are going to cancel out. If I do 12 plus 6, remember we're adding, I get 18C. Oops, excuse me, sorry, I did this wrong. Hopefully you guys caught this. Since I multiplied by -2, I need to multiply everything by -2. So I have -8S minus 24C equals -280. So hopefully you guys caught that and wondering what I was doing. So now -24 plus 6 actually gives me a -18. And -280 plus 100 gives me a -180. So now to get C by itself, I'm going to divide both sides by -18. And I get C equals a +10. Now I want to be careful with labels here. Since C we said is the price of a child's ticket, I have to include my $sign. So a child's ticket is $10. Now, we're not quite done because we said we were looking for the price of a child ticket and the price of a senior ticket. So I need to go back to one of my equations to solve for S. So I'm going to use this one here. I know 8S plus 6, well, C we said was 10, equals 100. So if I solve this, I have 8S plus 60 equals 100. If I subtract 60 from both sides, I get 8S equals 40. And then dividing by 8 on both sides tell me that S is equal to $5. Sorry that's kind of crammed in there, but hopefully you can follow how I was solving through. So now I found both the cost of the child ticket and the senior citizen ticket. All right, we'll do one more and then we'll save the rest for class. So let's see what we got. It says, let me adjust this, sorry about that. Jack and Betty have 28 coins that are nickels and dimes. If the value of the coins is $1.95, how many coins of each type do they have? So what we're looking for is how many coins of each type. Now we know there were 2 types here. There were nickels and there were dimes. So if I want to know how many nickels and how many dimes, I need to set up 2 variables. So I'm going to say for step 1 that N equals the number of nickels and D equals the number of dimes. All right, so let's go see what equation we can write based on the given information. So the first thing it says is that Jack and Betty have 28 coins that are nickels and dimes. So what that's telling me for my step 2 is that if I add up the number of nickels plus the number of dimes, I'm going to get 28 coins. So N plus D equals 28. The next thing I know here is that the value of the coins is $1.95. So now I have to be a little bit careful here. So I'm talking about the total value being $1.95. Now I know the value of a nickel is 5 cents. So I have to do 0.05 times the number of nickels plus my dimes are 10 cents. So 0.1 times the number of dimes is going to give me $1.95. And that's my system. Now, in this case, we have two different ways that we could solve this. We could use elimination, and we could easily multiply here, or we could use substitution. So, since I did elimination up top, just to show an example of both, I'm going to go ahead and do substitution in this case, which means I need to get one of my variables by itself, and it seems like the easiest way is to go here. So I'm just going to decide I'm going to get D by itself. So if I rearrange this, I know that D equals 28 minus N. So now I can go down here. So now we're really in step 3, and maybe I'll start that over here again. I'm going to use substitution, so I know 0.05 N plus 0.1. Now I'm going to substitute the 28 minus N for D, and I know that equals 195. So now I'm going to solve this equation for N. So I get 0.05 N plus, 2.8 minus 0.1 N equals 195. I'm going to combine up my like terms, and a calculator is really going to be helpful for you here. If I do 0.05 minus 0.1, I get negative 0.05 N plus 2.8 equals 1.95. So I'm going to subtract by 2.8, and I get negative 0.05 N equals negative 0.85. Now I can divide by negative 0.05 on both sides. And I'm going to need to go to my calculator as well here. You guys probably already have this up. Don't mind me while I figure this out. 0.85 divided by 0.05. And I'm going to get N equals a positive 17. Okay, so now N was the number of nickels. So to label it, I'm going to put N equals 17 nickels. Now I just have to go back and find the number of dimes. So I know N plus D equals 28, so 17 plus D equals 28. If I subtract 17 from both sides, I'm going to get D equals 11. So D equals 11 dimes. Now, we could have also solved this using elimination. Either way would work, but again, I just wanted to show one example of each method. So that is plenty for today. I'll answer any questions you have about this video, and we'll also look at a couple extra examples when we're back in class. All right, have a great day. Thanks.